Okay. Any ideas what a ratio looks like? How would you say? Eden?
So it's like, so a ratio could look like 5:6.
5 to 6.
Or it could be 5 to 7 to 6.
To 7 to 6, okay?
So ratios could have 2 or 3 numbers.
Ratios can have 2 or 3. They could actually have
4,
4, 5.
5.
There's some other things that I would like to include in there, like we've got 5 to 6, we have got 5 to 7, and then 7 to 6. Luke, anything to add for that one?
I have just a question.
Go on then.
Is ratios basically comparing numbers?
That's good, isn't it? Yeah. Comparing numbers, comparing one number to another, how much someone has. So we can have one thing there is the numbers. What was important about a ratio though? Had to be. No? So could I say we could have. Come on, computer. If I say apples to oranges, could that be like a ratio? And then if I said 5 to 1, that's a ratio. And does it matter what order the 5 and the 1 go in?
No.
But
Yes.
Ooh.
Yes, actually,
Because
Hang on then.
if you're
Jai?
talking about the amount of oranges and apples,
Yeah.
the apples are 5 and the oranges are 1. So you can't switch them around because that's what they are. Like, that's
Okay,
what
so
they
it
are.
is apples goes with the 5 and oranges goes with the 1. Yeah. Luke.
I was also meaning to say if the 5 is first, you say what is the ratios of apples to oranges because the 5 is the amount of the apples.
Exactly. Yeah. It is that. So does that cover what a ratio means? Actually, I think you've already done that then, haven't you?
Yeah.
You've already said it's how many of one thing compared, I like the word, compared to another.
A ratio is basically something compared to something else.
Yeah.
Oh.
Could we give other examples? So apples, remember the first ratios we did were involved with cooking? So how much sugar you needed compared to how much fruit or chocolate chips with flour, that kind of thing. Nick?
So, like, if in a word problem, if it says, like, Jimmy has, like, 5 apples, and Bob has, 1 orange, put a ratio of apples to oranges.
Yeah, it would say write that as a ratio. Yeah, exactly. What do we mean by an equivalent ratio, Jai?
A ratio that is equal. Example 2 to 4 is equal to 4 to 8.
Is equal to 4 to 8. Okay? So ones that would mean the same thing. Does that mean the same thing? Yeah. But if I say apples to oranges again, I've got 2 to 4. And this is also apples to oranges. Do they mean the same thing? Just checking. So does this one mean that there are 2 apples and there are 4 oranges? Does it? So then there are 4 apples and 8 oranges is not the same thing.
No, it's just equivalent. So if
So what do I need to add? There's probably another couple of words I need to add in to make it my sentence. Oops. Thunder.
We're like, this is piano.
Guys, there's probably another couple of words. So what if I said, for every 2 apples, there are 4 oranges. That means there can be more than 2 apples, okay? And there can be more than 4 oranges, but I know that for every 2 apples, there must be 4 oranges, and that makes sense, doesn't it? So now there are 4 apples, so there must be 8 oranges. So that's a kind of maybe useful, let me rewrite that, for every, maybe that's something that you would want to include. What does it mean to put a ratio in its simplest form? Luke?
Divided by two numbers. The sorry, divided by one number that goes into both numbers, so it cannot be divided anymore.
Awesome. Does anyone have that same set exactly right, but maybe using different words now?
To divide a ratio by a number that goes into all of the numbers, and the ratio until it can't do any longer.
That's pretty much what I think you confirmed what he said is right. There's a couple of other words. What do you reckon, Eden?
You divide the ratio by the highest number that can go into the.
Highest number. Another word? One more word. Nick?
To reduce the ratio down to its lowest form.
Okay, yes. Correct again. There is one word. Eden almost got there.
What Eden said is like,
So if I do 5 to 10,
is the word common multiple or something.
almost.
Highest.
Good, there you go. Oh, sorry, I'm thinking. Highest common factor, good. So what's the highest common factor of 5 and 10? 5. So we can, this is what Luke was saying now. Divide by 5, divide by 5, and I get 1, 2 to 2.
1, 2, 2.
And if that's the highest common factor, okay, you might, maybe you've seen it as HCF. Have you heard that before?
Nope.
No? Okay, maybe some. I'm going to skip that one for now. Do you remember how to share an amount by a ratio? Nick?
The example is like the Tom and Sean one.
Tom and Sean, yeah.
If Tom cleans 7 windows and Sean cleans 5 windows and they make $48, Tom will get more because he cleaned more windows.
Good, yeah. So Tom deserves more. He did more work, potentially. So to share that out equally, how would you share it, Nick?
Since 7 plus 5
Good. Is 12. So that's the 12 windows. Yeah. And then we do,
Divided by 48.
almost, you say this every time. You don't mean it, but you say it. What should we do division-wise?
48 divided by.
Good. So we're going to do the $48 divided by the 12 windows. And we get $4 for one window. Okay?
Tom cleans 22.
So he gets 7 lots of, which is actually
28.
$28. And Sean gets 5 lots of $4, which is 20. And we should just check, shouldn't we, that if we add them together we get 48, and we do, so we're happy. Okay? Right. Marley, you got up and moved. I want you to answer this question because you know, what does a proportional relationship look like?
What it looks like.
What does it look like? Did it yesterday. You knew this answer twice.
Straight line.
Straight line. Yeah, there you go.
Is that not?
Looks like a straight line.
That's very implicit number.
So you can do as you like, straight line, right, straight line. And then Sam, what point will every proportional relationship share? You gave us this at the end yesterday. Remember that, Samuel?
Oh, yeah.
0, 0, isn't it? It always goes to 0, 0. Because if you've not won any medals, how much money do you get?
0.
0. Good. All right.